Hi, I'm back again with another experiment from this book, Make Electronics by Charles Platt. Now, I am using the third edition of the book, and what has become apparent from some of your comments is that there appears to be substantial differences from the first and second editions. So if you have been following along with an older edition of the book and you see me doing an experiment that you can't find in your copy of the book, it's not that you're going mad, it's not that I'm making things up, it is purely that unfortunately that is an experiment that's been introduced in the third edition that wasn't present in the first or second editions. So I'm sorry if that happens. Unfortunately, I don't have access to either of the earlier editions, so I can't even warn you if that is the case. But if you do see an experiment that you can't find in the book, that is why. Okay, so we've got to the point in the book where we've now learned enough to actually be able to build and, more importantly, to understand a practical project. And that project will be a security system, a very simple security system, but nonetheless a security system that will work. And the basis of that system will be these things. So this is a reed switch. And basically, in this part of the switch, there are two sprung metal contacts that are normally held apart. But in this side is a magnet. And when you bring the two together, that will cause the contacts to come together and form a circuit to complete the circuit. And of course, the opposite will happen, that if the magnet is moved away from the other side of the switch, that the two contacts will spring apart and break the circuit. Now, this particular type of reed switch, you'll notice, has three terminals. One of those is the common terminal, but the other two basically give us an option of having it as normally closed or normally open. Now, we'll be using the normally closed connection because we want it to operate that there's normally a connection, and when that's broken, then the circuit is broken, rather than the other way around. And also because wiring things up in that way allows us to connect multiple switches in series. So just to demonstrate how these work, I have one here that I've wired up, and I've got it connected to the continuity tester on the multimeter. Now, at the moment, you're not hearing a tone because, of course, the magnet is nowhere near this side of the switch. But as I bring them together, you can hear that once the magnet got close enough that the circuit was made and we got continuity. Now, the idea is that this side, or one of the sides at any rate, this side most likely because it has the wiring, is connected to the frame of a door or window, whereas this side with the magnet is connected to the part of the door or window that will move when it's open. So the idea is that as long as the door or window is closed, we have a connection, we have a circuit. As soon as the door or window is open, the circuit is broken, and we can, of course, then detect that and sound an alarm or give some sort of alert. So let's have a look at what the circuit side of things looks like. Here's a simplified view of the test circuit for the alarm. To keep things simple, I'm ignoring the connections to the power and to the ground pins on each 555, and also to the control and the reset pins. I'm also not showing any component values. If you want that in the book, you'll find the full circuit with all the component values. Now, even in its simplified form, the circuit can seem confusing if you consider it as a whole. So the best thing to do to gain an understanding is to break it down into stages. So let's do that. So this is where our series of reed switches on our doors and windows will be connected. For the purposes of this test circuit though, they're represented by a single switch. And you can see that as well as being connected to the rest of the circuit, this switch is connected via a current limiting resistor to an LED. And that LED will be lit while all of our doors and windows are closed. Moving on to our first 555, its responsibility is to monitor for us pressing the button to start an exit delay, and then to give us a short window of time to leave the building before the alarm becomes active again. You might recognize from earlier experiments that this is wired up in monostable mode. Moving on to the second 555, its job is to monitor for a break in the circuit of reed switches. And when it detects this, it again gives us a short window of time in which to disable the alarm before it's set off. And once again, this is wired up in monostable mode. The job of the final 555 is simply to switch the alarm on after the time expires on the previous 555. Unlike the other two 555s, this is wired up in bistable mode, which means once it's on, it stays on until it's reset. So that's an overview. Let's now look at how it works in more detail. I'm going to ignore the first 555 for a moment because I think it's easier to explain that part of the circuit once we've seen how the alarm is triggered. So on this 555, notice that pin 2, the trigger pin, is held high by this pull-up resistor. You'll recall that the 555 is triggered when the trigger pin is brought low. So let's see what happens when our circuit of reed switches here is broken. So in the test circuit here, we simulate that with a single switch. So when that's opened, two things will happen. First, this LED will go off because it no longer has power. Secondly, this plate of the capacitor is no longer connected to a positive supply rail, so it will go negative because of this pull down resistor here. You might recall from an earlier experiment that through the phenomenon of capacitive coupling, this will cause a negative pulse on the opposite plate. And this will be enough to trigger this 555. So when this 555 is triggered, the output pin, pin 3, will be driven high. That will turn on this LED, which is telling us, hey, the alarm's been triggered. You've got a short window of time to disable it before it goes off. And because, again, this is a monostable configuration, we have an RC network here that determines that time period. And when that time period expires, pin 3 will go low again, so this LED will go off. And again, because of capacitive coupling, we'll get a negative blip on the opposite plate of this capacitor, which will be enough to trigger the final 555. Now this is wired in bistable mode, so when it's triggered, it will put the output pin high and it will just keep it that way. Now in the test circuit, this simply lights a final LED, but in our final circuit, it will power an audio circuit, so we get an audible alarm. Okay, so now we know how the alarm is triggered, we can come back to the first 555. So here, the trigger pin is once again held high by a pull-up resistor. But we have a push button here that we can use to momentarily connect the pin to ground, thus triggering the circuit. So that will trigger the circuit, will cause the output pin 3 to go high, which will of course light this LED. And this is now warning us that we have a limited amount of time to exit the building before the alarm is active. And once again, this 555 is wired in monostable mode. So again, we have an RC network that is setting that time period. Now notice that the output pin is also connected via a diode to the trigger pin of this 555. That means that while the output of this 555 is high, even if the reed switch is broken, and there will be a capacitive coupling pulse, negative pulse here, it will be overridden by the positive supply from pin 3 of this 555. So the alarm will not be triggered. Okay, so here's the built test circuit. So you can see here's our switch that is simulating the circuit of reed switches that would be on our doors and windows. This is our button that we will press when we want to leave the building to temporarily deactivate the alarm. And then we've got 3 more LEDs here. This is the one that will come on to tell us that we've got a limited amount of time now to leave the building before the alarm is activated. This is the one to tell us that the alarm has been activated, but we've got a limited amount of time to disable it before it goes off. And this LED is just telling us that the alarm has gone off. So let's see it in action. So as I said, this button will give us a short window of time. And in the final alarm, that will be around about 30 seconds. But here we've used lower value components because we don't want to have to sit and wait for 30 seconds. But what you'll see is that after I press this alarm, I will very quickly simulate opening and closing a door by turning this switch off and back on again, and that will not trigger the alarm. So let's give that a go. I'm just going to hold on to this switch so I don't pull it out of the breadboard. So there we go. There's that light. Open a door, and close the door. That light has now gone off to tell us that the alarm is now active. You saw when I opened and closed the door there, the alarm didn't go off because we were in that period of time. But now, if a door or window is opened, we get this light to tell us alarm's been activated, disable it quick. If we don't disable it in time, then the alarm will go off, which is indicated by this final LED. And of course, in the final circuit, that would be connected to some sort of audible alarm. Okay, this horrible rat's nest is actually the circuit now built in the form that it will take in the project box. Of course, we won't be using breadboards in the project box. I will be transferring these to these little half breadboard style PCBs. But just for this final test, I've left everything on the breadboards. You can see I've actually got 2 circuits now. So this is the alarm circuit. This is one of the audio circuits that we built in an earlier project that I'm using for the alarm portion of the circuit. And the other difference, of course, is that everything that will be panel mounted is now off the breadboard, hence the horrible tangle of wires. And you can see that for the moment, I'm just using a terminal block to connect everything. I haven't decided whether to use a terminal block in the box or whether to just solder everything up. I will have a look and see how much space I've got when I get to that stage. But for now, this is how it works. So now we've got, rather than the battery, we've got power coming in through the power connector here. We've now got a switch to apply power to the circuit. And when I do that, you might find it difficult to see very clearly on the video, but this LED has come on to indicate that our reed switches are closed. So now, if I want to leave the house, I can press this button, and you can see this other LED has come on. This is to indicate that I've now got a very limited window of time to leave the house. While that is still lit, I can open and close doors, no problem, as long as they're all closed again by the time this goes out. And there's a little over 30 seconds delay on this, so I will fast forward past the rest of this. So the circuit is now active again. So if the circuit is interrupted by one of the reed switches or more being broken, then again we'll get another delay. This time we get no indication. That's slightly different from the earlier test circuit. And again, I'll fast forward past this. And there the delay's ended and the alarm has come on. And now the only thing you can do to stop that is to basically power down the circuit. So the next stage is to get these components soldered up on these little boards here, and I will do them one at a time and then test them after I've done them. So here you can see I've started soldering up the first mini breadboard PCB. The first thing to note is I'm using a couple of sockets for the ICs just to reduce the risk of damaging them, especially with my poor soldering skills. It's a high likelihood. And also, of course, if they fail at any point, then it's easier to replace them. And I've started just by adding in the bridging wires because it's a lot harder to get those in once you start adding other components to the PCB. And then what I've also done is I've just checked continuity, both checking to make sure we haven't got any bridges and also just checking that we've got continuity across these little jumper wires. And all is good. So now I'm ready to carry on and add the rest of the components. Okay, we're back with the rat's nest, but this time with both PCBs completed. And there we go. There's our alarm. So now, let me just shut this up. So now, the next thing for me to do, now that everything is working, is to prepare the project box and assemble all of the pieces in the project box, hopefully with a lot less wire, and we'll try and get it a little bit neater. So I've got my project box here, and you can see I've used Adobe Illustrator to create and print out a drilling guide for each side. So this one is just for the bolt holes to hold the circuit boards in place. And this one is obviously for the front panel. So you've got the switch and the button, the two LEDs, the speaker grill, and the mounting posts for the connection to the reed switches. So the next thing for me to do now is just to get going with the drill and drill all these out, and then I can start mounting components. So here's the project box with most of the components mounted. I haven't put the second circuit board into place yet, just so that it's a bit easier to see what's going on. You can see that what I've chosen to do is to keep the terminal blocks. So I've got 3 sets of terminal blocks, just because if I want to go back in to repair something or modify something later, it's just easier to separate the individual components if they're connected that way rather than being soldered inside the project box. The reason for the nut here, by the way, is just because there are so many connections to ground. It was better to split it into 2 rather than try and jam everything into the same connector. And then on the front panel, you can see we've got our on-off switch,
We've got our button to start and exit delay. We've got our ready light and our warn light, and we've got our binding posts to attach the network of reed switches to. So the speaker and the two LEDs are just hot glued into the panel. Not very neatly, I have to say, but hey ho. And the terminal box are glued down as well, or at least they were. This one's decided to come free, but I'll fix that later. So basically, what will happen with this is that this sits sort of double-decker style. The second circuit board sits double-decker style on top of the first one. And I put the audio board on top just because it has the trim pot. So obviously it's easier then to adjust those if necessary. So I'll attach that board, I'll finish doing all the wiring, and then I'll give everything a quick test. So here's the finished item, all boxed up. For the purposes of this demonstration, I'm just hooked up to a single reed switch, but obviously you could have several of them in series. So the power supply is connected, so let's just fire it up. And there you can see the light coming on to indicate that we've got all our windows and doors closed at the moment, which is good. So if I want to leave the house, I can press the button, the other light comes on to say I've got a limited window of time. So during that time I can open a door and close it again so that I can leave the house. And I'll just fast forward past the delay, which is a little over 30 seconds. So now the warning light has gone off. So now if a door or a window is opened, you can see that connection is broken because our ready light has gone off. And now again, we've got a limited amount of time to disable the alarm. And if we don't disable it in time, and again, I'll fast forward past the delay. And there we go, our alarm has gone off. So that's everything working as it should do.
Wow, that has certainly ramped up the difficulty level from what we've had so far. But at the same time, it was very, very interesting and satisfying to take something from the breadboard to a finished practical project that could actually be used somewhere in the home. Now, in the next episode, the book takes us back to a breadboard-based circuit, and it will be another 555 circuit, but we're starting to get a little bit more interesting in terms of the user interface because it will introduce these things, a multi-segment LED display. So I'm looking forward to that. I hope you are too. Please join me then.